All right, here we go. The end of chapter 7. So after this, all of the chapter 7 homework can be done. So chapter 7 is going to be about confidence intervals. Okay. So let's talk about confidence intervals, and deal with that. And again, the central limit theorem is going to come into play in this because we will not find a confidence interval unless we can perform the central limit theorem. Okay? So confidence intervals, that's what 7.4 is about. And what is a confidence interval? Well, a confidence interval is a range of values so defined that there is a specific probability that the value of a uh, parameter lies within it. So, in other words, you're going to get a range of values, and somewhere in there will lie our population parameter, our population proportion. Okay? That's what a confidence interval allows us to know. So in this one, it's really specific that we will not know the actual population parameter, okay, the population proportion. We're going to be using p hat and all that information to help us out. And the interval that you come up with, that is what we call the confidence interval, okay? And that you'll have a specific probability value that lets you know that that population proportion lies within that interval. Okay? That's kind of it in a nutshell. But let's dive more into this so we can talk about it. So it is reported as the estimate plus or minus what we call the margin of error. Okay? So it is your estimate plus or minus the margin of error. Okay. So that margin of error is how far from the population value our estimate can be. Okay. And we denote margin of error M. So this margin of error, basically, this is our p hat plus or minus that margin of error. Okay, which we denote M. So it's like p hat plus or minus M. All right. And once you figure out that M, it's going to give you a range of values where that population value will lie in. Okay. All right. Just a couple other pieces of information that you should know. When you deal with a confidence interval, it tells us two pieces of information. Okay. It provides us two pieces of information. One, it provides us, as I've been saying, a range for possible values of the population parameter. Okay? Or in other words, our population proportion. Okay? It provides us a range of values for it. The other thing that it provides us is a confidence level. Okay? A confidence level measures our capture rate, and it's a percentage. Most confidence intervals you're going to run are going to be with a 95% confidence level. Okay? So again, that confidence level measures the capture rate for our method of finding the confidence intervals. More on this in a couple seconds. Okay? So again, the confidence level measures the capture rate, which is a percentage, for our method. It's all about the method of finding the confidence intervals. Okay? So another way to think about that is the confidence level tells us how often the estimation method is successful. How often our method is successful. Okay? So I want you to think about confidence intervals like this. And I took this example straight from the book. This is a great example. Okay? Imagine a city park. In this park sits a mother and her daughter, who is a toddler. Okay? The mother sits in the same place every day. okay, on a bench along a walkway. So the mother sits on the bench every day, same place, while her daughter wanders around her. Most of the time, the child stays very close to her mother, as you would expect. Okay. In fact, the study reveals that 68% of the days she's within 1 yard of her mother. Notice you've seen 68% before, and you've also heard it associated with the number 1, but it was in standard deviations. Okay. So this is relating back to that empirical rule where within 1 standard deviation is 68% of the data. Okay. Sometimes she strays a little bit further, but on 95% of the days, she's still within 2 yards of her mother. 2 standard deviations is 95% of the data. Only rarely does she move much further. She's almost always within 3 yards of her mother, which would be the 99.7%. Okay? Now, one day the unimaginable happens, and the mother and the park bench become invisible, unknown. Fortunately, the child stays visible. The problem is to figure out where the mother is sitting. That's what the confidence interval is all about. It gives you a range that the child would circle about, and somewhere between the child's distance on either side is mom on the bench. That's a confidence interval. Okay? So that's what this last paragraph says. Where is the mother? On 68% of the days, the child is within 1 yard of the mother. So at these times, the mother must be within 1 yard of the child. If we think the mother is within one yard of the child on most days, that is 68% of the days that we observe, that we would be correct. But this also means that we could be wrong 32% of our days that we observe the child. We would be more confident, which is why you often do 95%, of being correct if we instead guess that the mother is within 2 yards of the child. Then we would only be wrong 5% of the days that we visit. Okay? So a confidence interval, it gives you that range of values, and somewhere in there is that population proportion, or another, the end of the interval and, the beginning of the interval, the end of the interval, that's like the distance the child has run away from the mother. Okay? On either side. And then somewhere in there is mom on the bench. Okay? That's a confidence interval. I love this analogy because it kind of gives you an idea on that. And it also illustrates things that we already know. Okay? It also, remember that we talked about this before, that the population proportion is always the same. It doesn't change. We talked about that in 7.1. So that's why, up here it says that the mother sits in the same place every day on the bench along the walkway. That's the population proportion. The daughter represents the sample interval. Okay? So it definitely illustrates that idea that the population proportion doesn't change. But just so you know, confidence intervals will change with every random sample. Confidence intervals will change with every random sample. Just like every day that we come back and visit, the daughter goes different lengths around the mom. Different intervals. But the mom is somewhere between those intervals. Okay? So let's talk about some misinterpretations, because this is the big thing. So that confidence level that we usually like is 95%. So I want you to understand that that confidence level of 95%, so usually what we say is we are 95% or 95% confidence interval of 45.9% to 53.1% does not mean there is a 95% chance that the population proportion is in there. That's not what this level right here means. That confidence level is about our method, not the results. And remember that the population proportion does not change. So in this, if you interpret it as 95% of the time the population proportion is in here, that doesn't make any sense, because the population proportion, as we just said, does not change. Okay? I don't know why I opened that up. I thought I had the piece where it says it does not change. There it is. The population proportion does not change. I knew I had that written down. Okay? So, again, if you say that there's a 95% chance that it's in here, that means there's a 5% chance that it's not in there. Okay? And that doesn't make any sense, because the population can't be in two places. It's only in one place. It's either inside here or it's not. Okay? So it doesn't mean there's a 95% chance that the population proportion is between here. What you are talking about is our method 95% of the time will give us a population proportion within this range. Okay? It is about the process. We are 95% confident in our process that it is between here, not in the interval. All right? I'll give you an example of this here in a second to illustrate what I mean by the process. And again, as I said a moment ago, the population proportion does not change. Confidence intervals will change with every random sample. Okay? So please know that this 95% level is about the success of our method. Okay? Our method is 95% successful every time to produce an interval that has the population proportion in it. That's what that really means. Okay? It doesn't mean that there's a 95% chance the population portion is in here. Okay? So to illustrate that further, think about it like this. Here I have ran an experiment 100 times, and I produced a confidence interval every time. So that's what these little lines right there are. Those are my confidence intervals. Okay? The line down the middle here is the population proportion. Notice I ran this 100 times. How many times did my interval not contain the population proportion? 4 times. That's what these orange pieces are. That means out of 100 times, 96 of them matched, or sorry, not matched, but had an interval with the proportion in it. 4 of these did not. If I relate those to percents, because remember percents are out of 100, 95% of my intervals in here had the population proportion in it. Sorry, I said 94. 96. 4% of the time I was wrong with my interval. That's what we mean by this confidence level. So be careful when you interpret that confidence level. This 95% is about the process. 95% of the time, I will have my population proportion in there. The other 5% will not contain. Okay? That's what a confidence level is. All right? And we like 95% confidence levels. All right. Hopefully that explains a little bit about this, that it doesn't mean that there's a 95% chance that it's in here. It's a 95% chance our process produced the population or a confidence interval with the population proportion. It's all about the process, not the interval. Okay. So let's talk about the math. So here's what I told you in the beginning. It's our p hat plus or minus that margin of error. Okay? And so this will help you produce a number above and a number below your p hat. Now, here's how we find the margin of error. You're going to take your z-score, which is your confidence level. Okay? And over here, these are the actual numbers that represent that z-score answer. 99% is really 2.58 standard deviations. 95% is 1.96, which is why we say it's about 2. Okay? 90% is 1.645. 80% is 1.28. Okay? So these numbers are used in that Z star there. And then obviously you already know how to find the standard error. And this time it's actually using p hat because we do not know the actual population proportion. Okay? So this time you'll actually use p hat to find that standard error. And so when you take this number times the standard error, that gives you the margin of error. And then you can figure out your confidence interval. That's the math behind it. I will show you how to do this by hand once. Other than that, I'm going to use technology. Okay? And again, stress this again, we like to use a margin of error that is 2 standard deviations away. This will yield 95% confidence level. So 95% of the time, our method of figuring this out will produce an interval that has our population proportion in it. Okay? All right. So let's take a look at your assignment and the problems that you're going to have in it. So right here, I have given you an example where technology has already kicked out some information for us. This is from what we call Minitab. A couple things that you need to know. Right here, this is the number of successes. And right here, obviously, this is your total. Because that's important for us. Because these two pieces together give us the sample P, or in other words, our P hat. When I take this number divided by that number, this is where that guy comes from. Okay? So just wanted to kind of give you a heads up on that because that's important for us when we deal with our technology and how we run this in the calculator, the TI-84, and how we run this in StatCrunch. You need these two pieces of information. You need to know your successes and you need to know your total. Okay? So this says in November 2011, a Pew poll showed that 1,241 out of 2001 randomly polled people in the United States favored the death penalty for those convicted of murder. Assuming the conditions for CLT are met, because we can only find confidence intervals as long as CLT is met. It's got to be a normal distribution. Okay? We're going to answer the following questions. So we don't have to check CLT to this. We already know it's good to go. Okay? So down here it says using the Minitab output, the information, write out the following sentence. Fill in the blanks. I am 95% confident that the population proportion favoring the death penalty is between blank and blank. Report each number correct to 3 decimal places. Okay? And so they just want this information up here. Sometimes they will ask for it as the decimals, which I assume that's what they're doing. Sometimes it might ask for what the percentages are, because these are percentages up here. Because remember, that's what this is all about, a population proportion. It's a percentage. So if you do 3 decimals, this guy is 0.989. Sorry, I don't know why I said 989. 0.599. So 0.599, which if you convert that into a percentage, that would be 59.9%. And over here, this would be 0.61, or sorry, 41. So 0.641 or 64.1%. And there you go. So we'll talk about how we get this here in just a second for the next example. So then down here it says, is it plausible to claim that a majority favor the death penalty? Remember, a majority means that you have 51% or above. Okay, not 50%, because that's half. That's not a majority. 51% or above. So if you look at this confidence interval, do I have a majority? Absolutely. Because all of this is above 51%. Okay? I basically have 60 to 64% that say yes, yay to the death penalty. That's definitely a majority. Okay? So we start to take this information and we can start to, make assumptions and some inferences about the population. Okay. This was based off of a sample, but based off of the sample and the confidence interval, we can definitely say a majority of the people in the United States favor the death penalty. I don't need everybody. Okay. All right. So go ahead and pause the video and go ahead, pause the video, answer part A, and actually answer part B. You can do that, and then we're going to talk about part C together. Pause the video, answer A and B. Go. Okay. So, first thing with part A, it says, what is the percentage of those taking the poll said immigration was a good thing? So we know that there is 663 out of 1,004. So this is your successes. This is your total. Okay? So you just go to your calculator and you let it do the rounding for you. 663 divided by 1,004. And that gives us 0.660385657. And you probably had you round to 3 decimals or 2 decimals. So if you rounded to 3 decimals, it'd be 0.660. 4 decimals would be 0.6604. Then if it does say percentage, so as a percentage, that would be 66.035. I'm going to run out of room here. So as a percentage, 66.035855657%. I should put the percentage sign on there. So our sample found that 66% of the people think immigration is a good thing. Okay. So we check our conditions. All right. So again, is this random? Well, it's a Gallup poll, so yeah, usually we hope that it's random. Again, this first question of random and independent, you gotta assume is A-OK. So, I mean, really what they want you to check is the population huge, and do you have the number of successes and failures that you should have? Okay, that's what they want to check on this. But yeah, I mean, we have to assume that this was definitely done random and independent. Okay, Gallup polls, you got to trust that this is a group that knows how to do their surveying. Okay, so you got to trust that this is definitely random and independent. All right, so we'll say condition 1 is met. Okay, condition 2, again, this is that successes. I cannot spell today, or at least that looked like an E. Success and failure. So we're going to take 10 times our success, which is 0.6603585657. So 10 times that number gives us 6.60. Sorry, I said the wrong number here. Our total. It's like, this isn't right. It's our total times that. So 1,004 times all that. Today is an off day for Mr. Armstrong. It's not good. Is 663, and that's definitely greater than or equal to 10, so that's met. And then we'll take 1,004 times 1 minus our p hat, 0.6603585657. So 1,004 times 1 minus our number equals 341 greater than or equal to 10. So we definitely have failures met. And then last but not least, population. Is n greater than or equal to 10 times 1,004? So if we multiply that, we want to know, is n, let's get out of page width, is n greater than or equal to 10,040? So if we come up here, we are talking about U.S. adults. So do you think there are over 10,040 adults in the U.S.? God, I hope so. Okay, we have a lot of people that live here in the U.S., and our population is definitely, for adults, over 10,040. Okay, so CLT is definitely met. Okay, and then now we can find our confidence interval. Let me show you how to do this by hand first. All right, and we're doing a 95% confidence level. All right, so that means if we go back here, oops, too far, we want to use the 1.96. Okay, so that's 1.96. So here's how this works. We need to do p hat plus our margin of error. Our margin of error is going to be equal to the 1.96, because that's my z star, times the standard error. Okay, remember the standard error is going to be found taking our p hat, this 0, and I'm going to put this down below because again, I like to keep this as accurate as possible. The more you can be accurate without rounding, the better off you're going to be. Again, this is why we do this in the calculator, because the calculator will do all this information for us. Okay, but I want to show you how this works. So this is 0.6603585657 times 1 minus 0.6603585657. 5, 8, 5, 6, 5, 7. And all of that is over the total number of people we had, 1,004. So let's go to our calculator, let it figure this out. Okay, so we're going to take second square root, alpha y equals, and up top I got 0.66035.85657, parenthesis 1 minus 0.66035.85657. Close the parenthesis, all over 1,004. Uh-oh, said a syntax error. What's the matter? What did I do? Oh, I see it. I put in an extra decimal. I pushed a decimal instead of a 0. There we go. So this is 0.0149462.893. So that's what we're going to put here. 9462893. So we're going to take that number times 1.96. Again, this is why we don't do this by hand. We let the calculator do all the work for us. And we get 0.029294727. Okay? So all we're going to do then is take our p hat, which is 0.66035.85657, and we are going to add or subtract 0.029294727 to it. Okay? So using my calculator, we want to add that number. And so the top of our interval, I'm going to kind of put a giant parenthesis here, is 0.68, make that look like a 6, 6896532927. There's the top. Or if we made that a percentage, would be rounding to 4 decimal places, 68.97%. And then the bottom would be, we'll just take that same problem that we had and make it subtraction, would be 0.6310638387. Make these actually look like a 6 and a 3. Okay, so that rounded to 4 decimals would be 63.11%. And there you go. So that is our confidence interval. So the 95% confidence interval for the proportion who believe immigration is good is there at the bottom. Now let me show you how to do this using the calculator or using STA2023. crunch. Okay, I like stat crunch, but that's just me. All right, so if you're going to do the calculator, you're going to go under stat, and you're going to scroll over to test. And you're going to go down to number 7. It's called the Z interval because you're working with Z scores. When we know that this works with the central limit theorem, remember how I said you can convert stuff to Z scores because you're working with the normal distribution. And so the Z interval is what you want. So you hit enter, you scroll down to it, you hit enter, and you'll have 2 items here. It'll either have data highlighted, and again, you'll know it's data because it will have the black box around data. But what we want to do is we want to use stats because we have statistics. We know the standard error. We know the mean, okay, or p hat. And we know the n. So you're just putting that information in here. So you got to do kind of a little bit of work when you do this, but not much, okay? Because you'll actually have to figure those 2 pieces of information out. So if we go down to here, this is that standard error that we found, which was right here. So 0.01494. So 0.01494, if I remember right. Yeah. And then 62893. 62893. We know that this guy, that's our p hat, which is 0.66 0358. 0358. Then I believe it's 5657. 5657. And then you know how many people there were? 1,004. We want the 95%, so leave that the way it is and just hit calculate. And interesting, it was supposed to give us an interval. So let's go back. That was weird. Maybe I just accidentally skipped past it. So stat, test, interval. There's all our information. Actually, I think I know what this is doing. It's calculating the percentage for it. Oh, nope. There it is. Here's our interval. Although that one looks a little bit... That one's a little bit lower. But the 0.66128, I think that one matches. Nope. I wonder why that came out weird. Let's double check it with StatCrunch. StatCrunch. Now I know this one is because usually I deal with StatCrunch. I don't like working with the calculator. So we are looking for, if I remember, it is, oh, no, Z-stats. Oh, no, proportion stats. And you're doing a 1 sample with summary. Okay? You're doing proportion stats, 1 sample with summary. So you notice it says up here, number of successes, 663. Number of observations, too many. And then down here, we don't want that. That's for chapter 8. We want this. And so say compute. And there we go. There's that population. There's that standard error. Hey, there's our numbers that we came up with. See, I knew I'd do it right. It is just the graphing calculator. Let me look up the graphing calculator real quick, because in your book, if you haven't noticed, at the end, after all the review sections, they give you a yellow section, and in that yellow section, they tell you the tips for how to do this on the calculator. Here we go. There it is. So I did the wrong one. Let's go back. Let's talk about this. It's not a z interval. It is one proportion z test. I knew it had a z in it. Okay, I thought it was the interval because of the confidence. You're doing this. One proportion z. No, not test. That's the hypothesis. But it's down below. Here it is. One proportion z interval. I knew it. I knew there was an interval in it. It's right here. It's A. So again, go to stat, scroll over to tests, and you got to scroll down, and you want A. One proportion z interval. Hit enter. Here we go. Number of successes, 663, over number of trials, 1004. We want the interval at 95%. Hit calculate. Boom, there it is. And that matches what we had. I knew we were on the... I just went to the wrong one. I was under the right section. So again, stat, scroll over to tests, scroll down to 1z prop. And you plug in the same information that you do when you do StatCrunch. Okay? It gets the same information. Whew! All right. So I've shown you by hand. I showed you how you can use StatCrunch. Showed you how you can use a graphing calculator. Okay? I would not do confidence intervals by hand. Use the calculator. Okay? Use the calculator. Make it easy on yourself, please. Okay? And I've got one more problem. Go ahead, give this a shot and see what happens. And go. Okay, so for the Gallup poll, we had 441. So that is our success. And 507, that's our total. Okay? Adults said it was morally wrong to clone humans. Okay, of course. All right, now it says what proportion of respondents believe it is morally wrong? So you know how to find that. 441 divided by 507. So we go to our calculator, 441 divided by 507. And this one says proportion, so I know that they'll want this as the decimal. If it says what percentage, then it wants the percentage. So this is 0.8698224852. Okay? So if we actually rounded this, they probably want 4 decimal places. It'd be 0.8698. If they wanted the percentage, you could say it's 86.98%. I always like to, talk to you about everything. So the first thing they want you to do, find the 95% confidence interval. So I'm going to go back to StatCrunch, but I'll show you the TI-84 since I messed up on the first time. So let's go ahead and do the TI-84. So remember, you hit stat, go to tests, scroll down to 1 proportion z interval. Okay? Put in the 441. Put in the 507. Scroll down to calculate. And now you got it. So 0.84053. So 0.84053, comma. Our other one would be 0.89911. 0.89911. All right. So as percentages, those would have been 84.053%, comma 89.911%. Okay? So on the next one, actually, I'll do the next one. It says use 1.28 if you're calculating by hand. No calculating by hand. I'll do StatCrunch for this guy. So StatCrunch, we want 80% confidence interval. So if you were using the calculator, then up in that, under stat over in tests, what you would do whenever it's not 95%, you just come down here and change it to the percent. So this would have been 0.8. Okay. But since we're doing this in StatCrunch, let's go to stat. We want proportion stats, one sample with summary. So we had 441, 507. We don't want a hypothesis test. We want the confidence interval. And we're going to change this to 0.8 because we want 80%. So there's our interval. So let's see here. What do we have? We had, I think, 5 decimal places on that guy, right? 5, yeah. So let's do the same thing for this one. So with 80%, wrong one, we've got 0.85067, 0.85067. Make sure on that. Keep pushing the wrong one. 067. And then the other one is 0.88897. 0.88897. So again, as percentages, that'd be 85.067%. And this would be 88.897%. Okay, so now question D, which one is wider? Okay, so the wider one is actually the 95%. Okay, why is it wider? Because the higher your confidence level, the wider the range, the interval. Okay, the lower your confidence level, the lower the interval. Okay, so if I took this and asked an extending question, how would a 90% confidence interval compare to these? How would a 90% confidence interval compare to these two? Go ahead, think about that for a second. So the 90% confidence interval would be narrower or smaller than the 95, but wider or larger than the 80. Okay? The larger the percentage, the wider the interval. Smaller percentage, smaller interval. Okay? So there you go. That's what 7.4 is going to be like. There are your questions that complete Chapter 7. And I wish you luck and fun as you find confidence intervals. You stay classy, statistics students.